In this video, we will practice working with improper integrals. These are integrals that look like definite integrals, except they involve infinity. This is a BC only topic. This is a practice video, so we will run through several examples. However, if you have not yet watched the introductory lesson, you should definitely watch that first. This video will make a lot more sense if you do. You can either click the link that appears in the upper right hand corner, or you can find the link in the description. In number 10, we do not see an infinity on one of the limits of integration, so why is this an improper integral at all? If we let x equal 3, we would end up dividing by 0. That's why we have a vertical asymptote at x equals 3, and that is one of the limits of integration, and that's why this is improper. An improper integral will either converge to a single numerical answer, or we say that it diverges. But the first step to figure that out is to find the antiderivative of the integrand. To make that easier, I've rewritten it a little bit. We are always going to use capital F of x to represent the antiderivative, but be careful, we are not allowed to use this notation when it is an improper integral. We can't use 3 because that would cause a vertical asymptote. So do not use this notation at all. To find the antiderivative, technically I am doing a mental u substitution. If u is x minus 3, then u prime is 1. We always have to divide by u prime, but dividing by 1 changes nothing. So we can just use the power rule of integration here. Adding 1 to this exponent. So I'm adding 2 over 2. So that's going to give me negative 1/2 for my new exponent. Then we have to divide by the new exponent, but dividing by negative 1/2 is the same as multiplying by negative 2. Don't worry about the plus c. I think the antiderivative will be a little bit easier to work with if we rewrite it like this. The next step is to find two limits. We need to find the limit of the antiderivative as x approaches the upper limit of integration and the limit as x approaches the lower limit of integration. We can find this first limit by direct substitution. So we get negative 2 over the square root of 4 minus 3. That's negative 2 over the square root of 1, which is simply negative 2. I'm sure you can do all of that in your head, so I'm just going to put negative 2. We cannot do direct substitution for the second limit because if we plug in 3, that's when we are dividing by 0. That's why we have a vertical asymptote. So we have to think about this a little bit. As x approaches 3, the value of this denominator approaches 0. As the denominator gets tinier and tinier, the overall magnitude of this fraction gets larger and larger. Because the numerator is negative, capital F of x is approaching negative infinity. Therefore, this limit does not exist. Everything I just wrote in blue would be something you would do in your head. You would not write it down. When one of the limits does not exist, we use a very specific vocabulary word to describe the answer. We say that the integral diverges. Number 12 is obviously an improper integral because we see the infinity right there. Let's go ahead and find an expression for the antiderivative using a little bit of mental u substitution. If u is 3x, then we know u prime is 3. We always end up dividing by u prime. We will divide by 3 by putting a 1/3 in the front. After that, the antiderivative of e to the u is e to the u. Don't worry about the plus c. Next, we need to find these two limits, the one corresponding to the upper limit and one corresponding to the lower limit. We can find the first limit using direct substitution. Putting 0 in for x, we get 1/3 e to the 0. But e to the 0 is just 1, so we don't need to write that, and we get 1/3. We cannot use direct substitution for the second limit because negative infinity is not a number, so you can't just plug it in. However, to show you my thought process, I am going to plug in negative infinity, but this is improper notation, which you would not actually write down. As x approaches negative infinity, capital F of x approaches 1/3 e to the negative infinity. A negative exponent drops that e down to the denominator, so this is the same as 1/3e to the infinity. But that's just 1/infinity. In other words, we have 1 in the numerator, and the denominator is getting bigger and bigger. As this happens, the overall value of the fraction gets smaller and smaller. In other words, capital F of x approaches 0. Again, this is improper notation, so everything I wrote in blue should all be in your head and you should not write it on your test. If you do need to write it down somewhere to help you think, write it on scratch paper. The AP graders for the College Board do not want to see this, trust me. So the last step, since we have two actual numbers for both limits, we can find the value of this improper integral by subtracting the upper limit minus the lower limit. So we simply do 1/3 minus 0, which of course is 1/3. This is an acceptable answer all by itself, but I do want you to get comfortable with this vocabulary. We could also say the integral converges to 1/3. For number 24, we cannot find the antiderivative by substitution. It just doesn't work. So we will have to use integration by parts. If you are not familiar with integration by parts, you should watch that lesson first and then come back. You can either click the link that appears in the upper right-hand corner or find the link in the description. So the first step is to decide which part of this will be considered u and which part will be dv. Let's start with u. We can choose the best u using the acronym LIATE, which ranks the different types of expressions from best u to worst u. We see that we have an exponential factor and a trigonometric factor. According to LIATE, trigonometric is a little bit better than exponential for u. So let's let u equal cosine x. That means dv must equal e to the negative x dx. Taking the derivative of both sides, we get du is equal to negative sine x dx. We can take the antiderivative of both sides, doing a little mental u substitution. If u equals negative x, then u prime is negative 1. We always end up dividing by u prime. We can show that we are dividing by negative 1 by putting a negative sign in the front. After that, the antiderivative of e to the u is e to the u. Don't worry about the plus c. Next, we set up the integration by parts formula, starting with u times v, which is this times this. Then we have minus the integral of v du, which is this times this. Notice we have a negative times a negative, which is a positive. Now we are supposed to evaluate this integral. The problem is this integral is no easier to evaluate than the original integral was. So when we run into this, we have to use integration by parts again. So let's pick u and v, and again we will let u equal the trigonometric part, which in this case is sine x, and we will let dv equal the rest. So that's e to the negative x dx. Taking the derivative of both parts, we get du is equal to cosine x dx. And taking the antiderivative of both parts, we get v is equal to negative, there's your mental u sub, e to the u. So far, I have brought down everything that's in front of the integral. Next, I need to find this integral using integration by parts. But be careful. Notice that integration by parts gives you two terms. For that reason, I'm going to have to put everything inside of brackets. ultimately I will have to distribute this negative sign across in order to get the right answer. So a common mistake that students will make is to forget to put brackets around integration by parts, which will be mandatory if you have either a negative sign here or a number. Let's start with u times v, which is this times this. Then it's minus the integral of v du, which is this times this. I'm going to bring this negative sign out to the front and turn this minus to a plus. Next, I will distribute this negative sign and start a new column of work. So you're going to see a plus here and a minus here. Normally, it would be time to find this integral right here. But again, this integral is no easier to solve than the original integral. In fact, this integral is the exact same integral as the original integral. But that's where the trick comes in. Everything we have found so far is the value of this original integral. So let's set all of this equal to the original integral. So now we have this. Because these two integrals are the same, it makes them like terms in this equation. So I can combine them by adding the integral of e to the negative x cosine dx to both sides of this equation. On the next step, this will give me 2 integral e to the negative x cosine dx on the right-hand side. Remember, this integral is what we are trying to find. So if we can get this by itself, whatever's on the other side of the equation will be the antiderivative we are looking for. All we have to do is divide both sides by 2, so you're going to see a 1/2 in the front on the left. The left side of the equation is the antiderivative we were looking for. We can simplify this a little by factoring out the common factor of e to the negative x. This will be even more useful if we drop the e to the negative x down to the denominator and make it e to the positive x. Also, I think I will switch these around and write sine minus cosine. So here's the original problem and the antiderivative of the integrand. Now we are ready to continue the process of evaluating this improper integral. We just need to find the limit as x approaches infinity and the limit as x approaches 0. You should be able to find this first limit in your head. I'm going to show you my thought process using some invalid notation, so do not write this down on your test. If you do need to write something down, write it on scratch paper. Let's imagine what happens to the value of this expression as x approaches infinity. Sine x oscillates back and forth between positive 1 and negative 1, and so does cosine x. So the difference between sine and cosine can't be any less than negative 2, and it can't be any more than positive 2. So as x approaches infinity, the numerator is sort of stuck between negative 2 and positive 2. In the denominator, we have 2e to the infinity. Of course, 2 times e to the infinity is just infinity. So in the numerator, we have a small number between negative 2 and positive 2, while the denominator gets bigger and bigger. So the overall value of the fraction gets tinier and tinier. In other words, f of x approaches 0. So that's the limit. Again, this is invalid notation, so do not write this down on your test. The College Board does not want to see this. The other limit can be found by direct substitution. Putting 0 in for x, sine of 0 is 0, and cosine of 0 is 1. Of course, e to the 0 is 1, so this simplifies to negative 1/2. We can find the value of the improper integral by subtracting the upper limit minus the lower limit. So that's 0 minus negative 1/2, which equals positive 1/2. So the value of the integral is 1/2, or we can say the integral converges to 1/2. For number 32, we can find the antiderivative with a little mental u substitution. If u is x over 2, then u prime is 1/2. we always end up dividing by u prime. And dividing by 1/2 is the same as multiplying by 2. So we can put a 2 in the front. After that, the antiderivative of sine is negative cosine. So we'll have negative 2 cosine u. Don't worry about the plus c. Next, we need to find the limit as x approaches infinity and the limit as x approaches 0. But as x approaches infinity, the cosine oscillates back and forth between positive 1 and negative 1. So capital F of x will oscillate between positive 2 and negative 2. Therefore, the limit does not exist. We don't even really need to worry about the other limit. As soon as one limit does not exist, we already know the integral diverges. Number 36 will be easier to integrate if we rewrite this integrand a little bit. In this form, we can easily find the antiderivative using a mental u substitution. If u is 8 minus x, then u prime is negative 1. We always end up dividing by u prime, so we will end up with a negative in the front. After that, we can just use the power rule of integration. Adding 1 to this exponent gives us 1/2. So we have 8 minus x to the positive 1/2 power. Then we divide by the new exponent, but dividing by 1/2 is the same as multiplying by 2. If we multiply 3 by 2, we get 6. So this is the antiderivative, which is equivalent to negative 6 times the square root of 8 minus x. By the way, what makes this an improper integral? I don't see infinity anywhere. Well, if we let x equal 8, then we have 8 minus 8, so that puts a 0 in the denominator. That gives us a vertical asymptote at x equals 8, which is one of the limits of integration. That's why this is improper. Next, we need to find the limit as x approaches 8 and the limit as x approaches 0. We can find both of these limits by direct substitution. If we substitute 8 for x, we get 8 minus 8, which is 0. So that makes this limit equal to 0. For the second limit, if we substitute 0, that gives us negative 6 radical 8. The value of the improper integral is the upper limit minus the lower limit. So 0 minus negative 6 radical 8. This is just 6 radical 8, or 12 radical 2 if you simplify this radical. Why is number 40 an improper integral? Remember that secant is the reciprocal of cosine. And cosine of pi over 2 is 0. That means we have a vertical asymptote at pi over 2, which is one of our limits of integration. That's why this is improper. The antiderivative of secant theta is a memorized rule, natural log of the absolute value of secant theta plus tangent theta. We just need to find the limit as x approaches pi over 2 and the limit as x approaches 0. We can't use direct substitution for this first limit because secant and tangent are both undefined at pi over 2. However, we should be able to find this limit mentally. I'm going to show you my thought process using some invalid notation, so please do not write this on your test. Let's rewrite the antiderivative. Instead of secant, we can write 1 over cosine, and instead of tangent, we can write sine over cosine. As x approaches pi over 2, cosine approaches 0, and sine approaches 1. So we're not plugging in 0. These denominators are getting closer and closer to 0. So the numerator is 1, but the denominator is getting microscopic. So you should be picturing like 1 over 0.01, and then 1 over 0.00001, etc. 1 over 0.0000001, and so on. So the overall value of this fraction is getting bigger and bigger and bigger. Here comes the invalid notation I warned you about. Capital F of x approaches the natural log of infinity plus infinity, which approaches infinity. So the first limit does not exist. Don't put an equal sign. Remember, this is all in your head. Do not write this on your test. The College Board does not want to see this. No need to find the second limit. If one limit does not exist, the integral diverges. Why is number 44 an improper integral? If we plug in 5 for x, we get 25 minus 25, so we're dividing by 0. So we have a vertical asymptote at x equals 5, and that's why this is an improper integral. How do we find the antiderivative of something like this? U substitution will definitely not work, and if this were a plus, we could use arctangent, but since it's a minus, we can't do that either. We are going to need something called partial fraction decomposition. If you're not very familiar with that, you should definitely watch the introductory video first. Either click the link that appears in the upper right hand corner or find the link in the description, and then come back. The first step is to factor the denominator. Then we need to rewrite this integrand as a over 5 plus x plus b over 5 minus x. To solve for a and b, we need to multiply both sides of this equation by the common denominator. On the left side, the common denominator cancels out completely, so we are left with 1. When you multiply the common denominator times this middle term, the 5 plus x cancels out, and you are left with a times 5 minus x. When you multiply the common denominator times the last term, the 5 minus x cancels out, and you are left with b times 5 plus x. We can find a and b by plugging in values of x that will cancel out one term at a time. For example, if we plug in negative 5 for x right here, we will have 5 plus negative 5, which is 0, so this term will be gone. So let's start by letting x equal negative 5. On the left side, we still have 1, but on the right side, we have 5 minus negative 5. That's 5 plus 5. So we have 10a. Dividing both sides by 10 gives us a equals 1/10. Similarly, if we let x equal 5, this term becomes 0, and we are left with 1 equals, and here's 5 plus 5, so that's 10b. Dividing both sides by 10 gives us b is also equal to 1/10. Substituting 1/10 back in for a and b, we can rewrite the original integral like this. We can find the antiderivative term by term using a mental U substitution. For the first term, let's take this 1/10 and put it out in the front. So really we have the antiderivative of 1 over 5 plus x. Think of this as 1 over u. The antiderivative will be the natural log of the absolute value of u. So this is technically a u substitution. So do we need to modify anything else? Well, if u is 5 plus x, then u prime is 1. We always have to divide by u prime, but dividing by 1 doesn't change anything. So moving on to the next term, again, let's put that 1/10 out in the front. So again, we have the antiderivative of 1 over u. This time, if u is 5 minus x, then u prime is negative 1. So we will need a negative sign as we divide by u prime. But the antiderivative of 1 over u is the natural log of the absolute value of u. Before we start finding those limits, let's simplify the antiderivative. We can start by factoring out the common factor of 1/10. Then, let's use our properties of logarithms. Remember that natural log a minus natural log b is equal to natural log a over b. So this part right here should be the same as natural log 5 plus x over 5 minus x inside of absolute value. So here's the original problem and the new antiderivative. To evaluate the improper integral, we need to find the limit as x approaches 5 and the limit as x approaches 0. We cannot use direct substitution for this first limit because the antiderivative is not defined at 5. However, you should be able to do this in your head. I'm going to show you my thought process, again using some invalid notation. Do not write this on your test. As x approaches 5, the antiderivative approaches 1/10 the natural log of 10 over 0. Remember, we're not plugging in 0 here. We're imagining that the denominator is getting tinier and tinier. As the denominator shrinks to 0.01, 0.0001, etc., the overall value of this fraction gets bigger and bigger and bigger, approaching infinity. So the antiderivative approaches infinity, which means that the limit does not exist. Remember, this is all in your head. Do not write this on your test. No need to find the other limit. If one limit does not exist, the integral diverges.